Hello students, welcome to this video where I am going to go over the Excel project for Business 1210 Section E. The instructions, this PDF document is located in Blackboard under the Excel module. You'll get the instructions. I would recommend printing it off, and then you'll also be given this Excel spreadsheet to work with. So what we're going to do here is a couple Excel activities. So the first one is financial literacy. We're going to pay off a loan. It's a credit card amount that we have maxed out our credit card. We're going to pay it off under two different scenarios. Scenario one is using the PMT function, which calculates a monthly payment. And then the second scenario is the scenario established by the credit card companies that set the minimum payment necessary in order to avoid kind of any type of bad credit rating. So you'll notice that in the Excel spreadsheet, we're in section A, that every time you go over to the side, press delete or press any other button, the values in green change. So what we want to do is prevent those green cells from changing. So highlight the first three there, highlight, right click copy, and then without moving it, right click, click on paste special, and then values. And there we go. Over here it says 2.1% for me, so I'm just going to manually type that over, 2.1%. You can do the same thing, copy, paste special. But that's does the same thing. So we're going to, in the first scenario, pay off this credit card balance of $2,476 at 19.1% interest over 2 years. So our PMT function is PMT equals PMT bracket. We're going to use this FX button here to bring up this window. The rate is our annual interest rate divided by 12. Number of payments is 2 years. We're making monthly payments. And our present value of the loan is our credit card balance. We're going to put a negative sign in front of this value. And there you have it. We didn't need any of those other fields filled out. So basically it says that if we pay off or make monthly payments of $124.93, we will pay this off within 2 years. So let's go into our payment schedule. Our beginning balance is $2,476. We're going to link that, go equals, and click on that value. We rarely want to type in numbers into Excel, especially when they are located in the nice data table. Our interest is going to be a percentage of our beginning balance. It's going to be 19.1% in my case, divided by 12. Times our outstanding balance. So we're paying interest. The credit card company is charging us $39.41 in interest. Our payment is going to be this value there. Our ending balance is going to be the beginning balance plus our interest minus our payment. And we'll have to extend column E. So at the end of 1 month, we have made a $124 payment, $39 of that goes in interest. We're left with just owing, roughly $2,390. Now, a couple things as we are creating this payment schedule is that when we copy things down, because we don't want to we don't want to keep on having to enter the same formula many times. We can copy the formula down, but when we do so, we need to have certain cell locations fixed, or we need to have that cell reference either set as a mixed cell reference or an absolute cell reference. So anything in green here, we need to have those cell locations fixed. They're going to stay constant. So go into our interest. It says C4 divided by 12 times B11. We don't want C4 to move. If we copy that formula down, it's going to change to C5, then C6, C7. So we don't want that 4 to change. So we put a $ in front of that 4 for the cell C4. Same thing with the payment, we don't want, if we were to copy that payment formula down, it's then going to be, it's going to change from C7 to C8 to C9, so we want it to be held constant at C7. So this is a mixed cell reference. We can have an absolute cell reference, something with $2 signs, but we just need that $1 sign in there. Our ending balance is formulas that will change, or cell locations that will change, and our beginning balance, we don't want to hold that constant because our beginning balance for the second time period is equal to the ending balance of the month previous. So now, if we copy those three down, you'll notice that our payment stays the same, but our interest is a little bit less. We know that we're going to have 24 payments because we're paying off this loan in 2 years. You're going to have a different value. I should go to roughly about there, I think. 2 more down. I think the loans, this activity is set to be somewhere between 2 and 4 years. So you'll get a different value. If it's 3 years, you just got to go down until it says 36. We can copy this last row down. Oops. You can go Control C or right-click copy, or you can kind of move it down, drag it down like that, and you'll notice that our balance here, there's some rounding differences, but basically we have paid off this loan in 2 years, 24 months. So it basically shows you at the end of every month how much money is still owing, how much money you're being charged on interest, and where your payment is going to. So there's some questions I have. The total interest, we're going to use a sum function. So go equals sum up here, bracket, and then highlight, drag over all of the interest. We paid $522 in interest. Our total payments equals sum times, or sum bracket, highlight over all your payments. This would be the same as going the payment, PMT, times 24. And we know that we have paid this off in 2 years, 24 months. So there, $2,476 plus our interest of $522 gives us our total payments of just under $3,000. So the second scenario is one that credit card companies use, where they don't specify that the monthly payment has to be that payment determined by the PMT function. They allow you to make a monthly payment equal to a certain percentage of the outstanding balance, or $10, whichever is greater. So we're going to go with that process here. The percentage of the payment I'm using in this example is 2.1%. This is going to range from anywhere from 2% to 3.5%, I believe. So our beginning balance is the same. Beginning balance is that credit card balance. Interest, it's going to be the same. It's going to be that 19.1% in my situation here. My example, divided by 12 times the outstanding balance. And you'll remember that because we're using a value from the green shaded in data table, we need to put a $sign in between the C and the 4, because we will be copying that down, and as soon as we do so, it's going to change. The cell locations will change. It'll be C12 or C5 times divide by 12 times B12 and so forth. So we don't want that C4 to change. Our payment is going to be that percentage payment, 2.1% in my example, times the outstanding balance. But this only works if the payment, if that percentage payment we've calculated is greater than $10. As soon as that payment, and we'll, as we go through this, we'll see that the payment eventually is going to be less than $10. So the credit card company basically says, at that point, just pay $10. So we don't want to have to go through this and actually go and find that cell and change that value and other values to $10. What we want to do is have it all set up in one. So we're going to basically have an if statement here. That if the interest is greater than $10, charge the interest. I mean, if the payment that we would calculate is greater than $10, charge or require that payment amount to be made. If not, it's $10. So if the 2.1% times the beginning balance, if that's greater than $10, then go ahead and pay that percentage times the beginning balance. If not, we're going to enter 10. Basically, this says if the required payment is greater than $10, pay whatever that percentage payment is going to be. If not, $10. And we'll see here that it turns out to be $52. We need to go into this formula, and every time where it has that cell reference to I3, we need to put a $sign in that. Oops. $sign, not a, there we go. Oops. No, I really messed this up. There we go. So things happen. And our ending balance is beginning balance plus interest minus our payment. Let's stretch that out. And we can do the same thing for the second month. We have to do this a little differently here. We can copy these three down. And then we can go ahead and copy these ones down here. And it's going to be a little longer than that. Basically, we're going to go down until, still not negative. After a couple hundred payments, it's still positive. Okay, it's almost done here. This is scary. There it is. So once it goes red, basically you want to go to that first red value, and we're going to change that payment. We only owed $3.12 plus 5 cents in interest. So basically this last payment is going to be $3.17, and we can get rid of the last payments here. Let's go back way up to the top here, and we can just cheat a little bit here. We need to put these values in there, and then we can highlight 3 of them and drag them down. It should kind of continue that that series. And look at that, 414 payments until it's 0. Let's go back to the top. A lot longer than 24. 414 monthly payments. So scenario 1 or scenario 2, calculating the total interest equals sum, highlighting all the interest. Oh, $6,683 in interest. Total payments is going to be the values in the payment column. Your last payment will have to be manually adjusted. Look, we paid $9,159 to pay off a loan of $2,476. Total time, it was, how many months do we have? 414 months. So basically 414 months divided by 12 gives us 34.5 years. There you go. Good life lesson here. This does happen. If you follow the credit card's minimum payment requirement, it's going to be more than a mortgage in terms of the time it's going to take you to pay off that balance. So always make more than the minimum payment, than the required minimum payment. So that's the first part of this Excel project.